So cellular telephony goes by the G's. G stands for generations. The first generation 1G, 2G, 2.5G, 3G, 3.5G, 4G. Right now we have 4G, 5G is coming. Right? So the 1G was started from the North America, amps. Okay? And of course the Europe is different. They started with TACS, PACS, and then quickly people moved on to second generation, and so on and so forth. The main differentiator between the generation is the technology and the workload. So the first generation was all analog. So they didn't. You take your voice, and your waveform looks like this. They transmitted that waveform, not zeros and ones. Okay, that waveform was transmitted onto a radio wave, on a sine wave, and demodulated at the other end and played back. That would be analog transmission. And obviously it was only for voice. Basically, of course, data you cannot transmit like that. So, and they didn't even think about the data at that time. So the analog, the 1G was analog and FDMA. Frequency division multiple access. So everybody got a different frequency. So if I am talking on the phone, when I talk, I tell on the control channel to this cell tower that I want to talk. They will say, okay, I'll go on to channel number 433. Then I transmit on 433. And of course, 433 also has a reception, corresponding reception channel, because you get two channels, right? The channel pair. So you talk on this and receive on this. And then when you went away, then somebody else got 433. So that was the way 1G worked. And pretty soon they realized that this is not the most efficient use of the spectrum or the best way to send voice. So they became digital. What does it digital mean? That instead of sending the wave pattern, they digitize the wave pattern. So at every point they measure how high, and made it a number and sent that number. Binary number. At the other end, they got the number and made a square waveform, which after smoothing became very similar to what it was in the beginning. I like the digital. So that is 2G. It's still voice. And then they started getting they started feeling need for data. So then they started updating, and so they came with voice plus data, 2.5G, more data in 3G, and so on and so forth. And 4G is almost all data, and 5G is 100% data. Voice is just a noise. So as you can notice, the other thing it says is that this was FDMA, this was TDMA and CDMA. 3G was all CDMA, and 4G is all FDMA.
I'm not sure what the difference between the voice and the data is.
Okay. So what is the difference with voice and data? Two big differences. First of all, data is not in a hurry. Voice has to reach there within whatever microsecond, millisecond there. If something got out of order, you lost it. Right? So data can wait. Voice cannot wait. Right? Second thing is the bulk. Data is so big, voice is so little.
Isn't 4G still used? Is that not used for voice too?
Yeah, right. So thing is, here's the thing. When you previously, if you go back, well, even now they're trying to do it. Previously, they used to charge you for how many minutes you talked. Now they don't charge you for the minutes. They charge you for kilobytes and megabytes, and then you get 100% all you can talk. Because all you can talk, if you talk for the whole month, it would be so little. As compared to the data, if you send 2 files, you are done. You watch 2 movies, you are done.
So the representation is not changed?
Volume. So the thing is, so the voice is, here is another thing. Voice was very quality of service sensitive in the beginning. Now what people have done is they have made ways of transmitting voice over normal IP networks, such that even with some delays it sounds okay. Okay, so it has become data. So voice can be sent almost like a data. So on the 4G, when you talk, all they are doing is sending some packets from here to there, and probably giving a little bit priority to voice traffic, because still, voice is in a hurry.
It's reliable enough that it doesn't really have to differentiate between voice and other data.
Reliable enough?
I mean, like, it doesn't have to.
Well, that's another difference. I don't know if you're talking other things. So, thing is, in the voice, if I say 7 and you heard 8, not a big deal. In the data, if I send you $7,000 and you got 8,000, I would be very unhappy. So the voice is error resistant. I mean, error not acceptable. I mean, the thing is, with the voice, in fact, so basically in the voice, if you error rate could be higher, but the hurry it has to reach. Let me say another way too. So now voice writes the data train. Basically, the main train is data, and the voice is sitting somewhere there, right? In the previous days, when we used to have modems, have you used modem ever? Modem?
Yeah.
You don't remember? Maybe you were a child. In those days, the modem was basically you took the data and made it a voice and sent it over the voice line. So you took a digital number and make it sound like some voice waveform, modulated it, sent to the phone company, and then the thing was that this was the beginning, right? When the phone company was analog, the phone company became digital, but they did not provide the digital interface to the customer. So the customer still had this phone only. They take their phone, dial a number, and put it on the modem, and then they can connect, right? So that modem's job was to convert the data to, right? Nobody has used that. None of you have used that phone modem, right? So that is before your time. But basically, so what it was the main train was voice. The data was just somewhere, sometime. Now the paradigm has shifted. The main train is data. The voice is somewhere, sometime. Yeah.
Why international calls now charge by minute?
Huh?
Why international calls now charge by minute?
By minute. Yeah, that will go away. See here thing. Let me tell you. This is all changing. I don't want to sell telephone company here right now, but there are phone companies that are offering plans which do not cost you minute. You just pay one time per year, international calls. And if you haven't looked into it, just look into it. And so these things are going away. All right, back to 4G. So several things. First of all, we are moving from voice to data, and from whatever the original phone company's protocols were, which we are not going to teach you here, to IP. Okay? And from, in the case of access, from FDMA to OFDMA. Alright? So you can see the trend as to how things are moving. And another trend was actually, and that was another thing which was constant pain, was that America was always different than Europe, or Europe was always different than America. And the reason was everything was invented in America. I'm sorry. Some people might object to that. Everything was invented in America, and by the time it went to Europe, they made it better. Alright, so they have a better system. Electricity. It started in America, 125 volt, 60 hertz. Now 60 is not a good number, and 125 is not a good number, but we got stuck with it because we started with it. By the time it reached Europe, they said, no, let's have the voltage 220 because then your current is less, your wires are thinner, and blah, blah, blah. Okay, so they got 220 volt system, and the rest of the world has 220 volt system. And 50 hertz is a better number than 60, and so on and so forth. And you go on to the television, same thing. Invented here, better over there. Telecommunication, invented here, better over there. So by the time it gets there, it is different and in some sense better. Yeah.
Just out of curiosity, do you know why phone plans are just so much cheaper in Europe?
What? Phone plans?
Yeah, data plans especially are maybe half the cost that they are. For example, like in Britain, everything's more expensive except the phone plans, which are like.
Okay, I don't know that, but basically, I think the plan, etc., mostly does with what the customer can afford. In India, it is 6 cents, 6 paise, which is like 1/10 of a cent or something. So how much customer can afford, right? So maybe their income level is low, or maybe people here make too much money. I don't know. All right, back to the technology here. So I just want to say that there are two trains you see here. This is European and this is American. Luckily for us, that coming here the trains collapsed basically. So now there is only one train going onwards, at least in the phone system. So you can use the same phone here and same phone there. Previously, there was no way to do that. And so the system in America, which was 2G, was based upon CDMA. And CDMA, by the way, is invention of Qualcomm, a company, an American company. And so it started here, CDMA. And there were other systems like TDMA systems and another digital amps, which is again FDMA in digital. All of those went away. And CDMA became what they call EVDO and EVDV and so on and so forth, CDMA 2000. So here basically in North America, Qualcomm sold out basically the technology called CDMA, right? And you know what CDMA is, right? Code division multiple access. And then basically it reached Europe. So this third generation of Europe is all CDMA. And so second generation, they had GSM, which actually was a good technology, again better than the American technology. So it went worldwide, GSM, and now it has come back to America. So Americans use GSM. AT&T is GSM, T-Mobile is GSM. The only company, and Verizon is CDMA still. So we have two systems. You cannot use phone from Verizon to AT&T, and so on and so forth right now. But so CDMA and so now in 3G, everybody is CDMA. The main difference is in 2G. So when you say Verizon versus AT&T, it's the 2G part that you cannot use. And the voice is mostly on 2G. So when you make a phone call, they still send you through the 2G system that they have. Okay? And that's why, the problem. If you just did the data, then maybe, it will be similar. But anyway, what happened was there were two organizations, 3GPP and 3GPP2. Third generation partnership project. And this third generation project partnership or something like that. 3GPP2 was for America and 3GPP for Europe and the rest of the world. And in the middle there is a fork here, China. This is the fork I was talking about earlier. So China decided not to go with the rest of the world, and they decided to go on TDS CDMA. And then finally they decided this was not good. So everybody had joined here to LTE. In fact, America was trying to do UMB and they cancelled that and they joined LTE CAN. So now the whole world is LTE, moving to LTE advanced and then to 5G. The networking industry tried to get into the game of the telephony, and so Intel took the lead and started the WiMAX. Okay? And WiMAX was the thing which was happening in 2009, and I was working with them from 2006 to 2009. That was the peak period of WiMAX. In 2009 it was done. Basically it was all technology was done and there were trials and everything else. But then suddenly Qualcomm and other telephone companies people came in and they said no, we cannot take this technology. And they just took the technology and renamed it with small changes to LTE. Okay, so the Intel is out of business and Qualcomm is back in business. And we have LTE, which is the worldwide, which is very same as WiMAX. I mean, I can give you the lectures after lectures, very small differences. But the big differences are in the telephone company's own business, because this one is an evolution of their old 3G thing to 4G, whereas this one would have been a total replacement in some sense because it's coming from the networking industry. Right? So it didn't worry about any of the old legacy stuff. So that is the thing. This is evolution. And by the way, LTE, E is for evolution. And I don't know, this must be European English, that everything, when they say, next generation, instead of next generation, they say evolution. Okay? So, edge is an evolution, evolved edge, and then LTE is another evolution. Okay? So, that is their word for next generation. So, there are lots of acronyms on this. They're all explained at the end. I don't think it is worth going through the acronym because I don't have time to explain each of these right now. All I want to do is go into GSM because that is the key, and everything else has kind of died. right? And we'll go into LTE later on, I mean, after this, but I think that's mostly it, right? All right, so just recapping. 1G was analog voice in terms of payload. FDMA, frequency division multiplex access, mostly 1980s. 2G, and by the way, these generations used to happen every 10 years. Telephone company, basically actually it could be 12 years or something like that, maybe even. So basically the ITU used to meet every 4 years. And so, okay, all right. They will work all through the 4 years, but every 4 years they will have a big meeting and they say, okay, this is the next generation of our telephony. So they used to tell 10 years every year, right? So anyways, 10 years. So 1980s was FDMA and this one. 1990s was 2G, digital voice, TDMA. And then there was some CDMA and other things. And GSM. And then 2.5G, because they couldn't wait for 10 years. So in 1995, they updated that and to all these other things, and which some of these we'll explain a little bit later on. And then 3G came out, which is all CDMA. So one thing about 3G is that whether it is Europe or here, everywhere it was CDMA, even though the European CDMA was different than our CDMA, I mean the American CDMA. And so but with all CDMA, okay? And now, I mean 3.5G is somewhat mixture, and then 4G is all FDMA. So WiMAX is there, but it is so little that I don't want to talk about it here now. So WiMAX was 3.9G, and then WiMAX 2 is 4G. And 5G would be 2020. So in 4 or 5 years, we will have next generation. So, and you can see there is third trend too, is that the data rate is going up and up. So it might have been few kilobits. In 2G, it was like 900, maybe 100 kilobits or something. And in 3G, it may have gone to 10 times that or something. Let's see. By right now in 4G, you can get up to 100 megabits. And if you have a very good system, you can maybe 1 gigabit. But here in 5G, we're talking about 100 gigabit and things like that. So, very high. Okay. So how we'll get there, and that is something. So the rate is going up. The access method is changing. And the payload is changing.